Alright, in this video we are going to practice graphing the cotangent function with a period change and a phase shift and a vertical shift. Now, keep in mind that the cotangent function is the reciprocal of the tangent function. So if we know how to graph tangent, it'll help us graph the cotangent function. I need to rewrite the equation before I do anything else. So this b value needs to come outside of parentheses. So I'm going to pull the 2 out there, and then inside I'm going to have x plus pi over 2. All right, so I'm going to have all of that and then the minus 3. So this is really the function that I'm about to graph. Now, I see that we have a phase shift. See that pi over 2? So that means that the phase shift is actually negative pi over 2 to the left. The period. Anytime we want to know the period, we always do the normal period divided by b. For tangent and cotangent, unlike sine and cosine, what's the normal period going to be? It's just pi. So when we go to find the period, instead of doing 2 pi over b, we're just going to do pi over b. So since the b value is 2, then that means that the period is simply pi over 2. Now, anytime we have a phase shift, what I recommend is start with that when you do your graph. Start with the phase shift. When you're graphing tangent and cotangent, also keep in mind that you are required to give me 2 periods of the function. So because we're going to do one on the right and one on the left, then I'm going to put this phase shift in the middle to leave space to do that. All right, so here's my x-axis. And even though normally we would put 0 in the middle for tangent or cotangent, because of the phase shift, I'm going to put negative pi over 2 right in the middle. So here's negative pi over 2. Now I'm going to count 4 spaces to the right. That'll be a period, and I'll count 4 spaces to the left. That'll be another period. So here I go. 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. It's important that we label all of these values. So I'm going to use the fact that every one of these values is a quarter of a period. So I just need to figure out what is a quarter period. That sounds good. I heard you say pi over 8. Sure, if the period is pi over 2, then a quarter period is 1/4 of pi over 2. So that is going to be pi over 8. So basically, I need to add pi over 8 to my phase shift in order to get the next value over. So that's what I'm going to do. I'm just going to add pi over 8 over and over again. Okay, so here I have negative pi over 2. Now if I want to add pi over 8, I need like denominators, so that's why I'm going to multiply this by 4. And that's going to give me negative 4 pi over 8. So that's what I'm going to start with, and then I'm going to add basically 1 pi over 8 to that over and over again. So if I add 1 to negative 4, I get negative 3. So that's negative 3 pi over 8. If I add again, I get negative 2 pi over 8. The next one should be negative 1 pi over 8. And the last one should be 0. Okay? Now, I'm also going to need values going to the left. So going to the left, I'm going to decrease by pi over 8. So the next one to the left should be negative 5 pi over 8. And then negative 6 pi over 8. Negative 7 pi over 8. And negative 8 pi over 8. I've left myself space to reduce these, so that's what I'm going to do now. Negative 3 pi over 8 cannot reduce, but negative 2 pi over 8 is negative pi over 4. And then I've got negative pi over 8 and 0. Over here on the left, I've got my negative 5 pi over 8. Negative 6 pi over 8 is negative 3 pi over 4. Negative 7 pi over 8 can't reduce. But negative 8 pi over 8 is just negative pi. Okay, so now I've got all the values that I need to graph this function. Just get this stuff out of the way. All right, now we're going to need the y-axis on this graph. Where am I going to put the y-axis?
Negative
3. Y-axis will always be at the same x value every single time. 0.
Well, I mean, yeah.
Oh, you're talking about, you were thinking the midline. You were thinking about the midline. Okay, I'm with you now. I'm all caught up. But the y-axis will go at 0 over here. So I'm just going to erase that 0 and put a line there. Okay, I think I'll make it a green line for some reason. Okay, so the y-axis is going to be over here. Okay, now coming up, I see that we have a downward shift of negative 3. So that's why I'm going to count my way down like this. I've got negative 1, negative 2, and negative 3. The amplitude is just 1, so I'm just going to go down 1 more because of the a value. Okay, it's not really the amplitude for a cotangent function because it's infinite, but I still will need that a value. So this negative 3 is going to be my midline, so I'm just going to make this dotted line for my midline. I'm going to make 2 more dotted lines in yellow for the a value. All right, up 1 and down 1 from the midline. Okay. Now, I really want you to memorize the basic look of the tangent and the cotangent function. Let me just switch to a blank sheet of paper for a second. I want you to memorize the following. For one period of the tangent function, if this is the midline right here, we've learned that the tangent function begins and ends on the midline with an asymptote right in the middle. All right, just memorize that that's what a period of the tangent function looks like. On the other hand, compare that with the cotangent function. For the cotangent function, all right, again, here's a period of the cotangent function. Instead of beginning and ending with a point on the midline, cotangent begins and ends with an asymptote, and it has a point in the middle on the midline. So just memorize that. Memorize that relationship. One more thing. Tangent function is always increasing as you approach those asymptotes, like this, whereas cotangent function is always decreasing, like this. So this is cotangent that we're doing. So cotangent should begin and end every period with an asymptote. So remember, our phase shift was negative pi over 2. So that means right here is the beginning of the period, right here in the middle. So there should be an asymptote here. And really, where we have the y-axis over here, that's another asymptote. I know it's hard to see. And then over here at negative pi, that's another asymptote. But for cotangent, every period begins and ends with an asymptote. And for cotangent, there should be a point right in the middle of each period on the midline. So there will be a point right here, and there will be a point right here. And then cotangent is always falling. As this graph is falling and falling and falling towards the midline, halfway over it has to hit the A value. So it has to hit this point as it falls. So it's going to fall because cotangent is always decreasing, but I have to make sure that I hit that point that is the A value above the midline. Same thing on the right hand side. Halfway over, it has to be at the A value below the midline. So as it continues to fall, I'm going to make sure that I hit that point as it's falling. And it'll be the same thing on the right hand side. I'm going to pick up high and fall towards the midline, but halfway over, again, at negative 3 pi over 8, it has to be at the A value above the midline. So it's going to fall, but it has to fall through that point as it falls. And same thing on the other side. Halfway over, it has to be at the A value below. So it's going to continue to fall, but as it falls, I have to make sure I hit that point as I approach the asymptote. So that's what the graph is going to look like for the cotangent function. And just real quick, as far as x-intercepts, let's just cross that out because we need a graphing calculator for those. But the vertical asymptote. The first vertical asymptote, well, there's one at 0. So let's start with that. We have a vertical asymptote at x equals 0. And then I noticed that the asymptotes are a full period apart. So I'm going to just add a full period. And the period is pi over 2. So I add pi over 2. And I just put a multiplier. I'll put an n on here. So I'll say n pi over 2. To capture the fact that I have many asymptotes repeating forever. Now we don't really need the 0, so I'm going to erase that. And I will just mention that n is an integer. And that's it. Alright, I hope this video was helpful. I will see you on the next video.